The inverse square law is a law used in physics, and it explains a lot of things about quantity and intensity and how it is inversely proportional to the square of the distance. And all that sounds really complicated. It's not. And we are doing experiments to help you understand this physical law. Welcome to Nugget 380. The nugget that we will be referring to in this video is Nugget 378. Now, to the inverse square law. If you're watching this video and you have not subscribed yet, can you just take one little second and do that right now?
They say the two bodies have an attraction to each other. They use it mainly for the planets and the gravity is what they say. But evolutionists say that the inverse square law, two bodies have an attraction to each other. The degree of the attraction is inversely proportional to the square of the distance between them. If you half the distance, you quadruple the attraction. If you double the distance, the attraction is 4 times less. But in addition to that, so is the apparent size, and so is the apparent luminosity, the visual light that you can see from.
We did the luminosity test on Owens Lake. The inverse square law is really important in photography and stage lighting, isn't it?
When I do interviews, they want to make sure I'm in the exact right place in the studio because that's where the light is. And if I'm too far away, it's dull, and if I'm too close, it's bright. It matters, and just a little bit of distance makes a huge difference. The point with the car we had done on Owens Lake shows that the apparent size of something is smaller at distance and smaller at more distance. And that comes into real importance here at the end of this nugget.
All right, so we did this one on Old Highway 395 north of Independence here in California. And here's a picture of our Tahoe from 10 feet away.
And here it is at 1/2 of a mile. And now at 1 mile. Back at a half, and back at 10 feet. And if you notice when the video is zoomed, notice how grainy it is because it really has to get quite zoomed up in order to see it at 1 mile.
Right, you can, if you have the proper lens, binoculars or camera.
You can pull it back in, but yes, you have to have some kind of piece of equipment.
Right, our eyes can't do that.
Correct.
Basically, what we did was take the inverse square law, use our truck, turn on the headlights, back up 1 mile to show that the light diminishes.
To the point you can't even see it.
Right, and drive back.
But if those headlights all of a sudden were 2.59 billion times larger than they are in the first place, then we could see it.
Right, but they'd be super blinding.
Right, because that's what it would take in order to see them back at that distance.
When they came back to you.
But reality says that's not true.
If they were that big and that bright, they would have wiped you off that.
It'd have been kind of rough up close.
Right? And then the other one on the sides, you just can barely see the Tahoe at 1/2 mile, and you really can't see it at a mile.
At 1 mile. Can't see it at 1 mile. You have to zoom in to see it at all.
Go do your own inverse square law experiment.
It's fun.
Math can be fun.
It absolutely can.
Thank you for watching our nuggets, and thank you for those of you that have subscribed. If you're watching this video and you have not subscribed yet, can you just do that right now? Thank you.